everyone. Today I'm going to be teaching you how to draw compositions of reflections in parallel and intersecting lines. Remember, compositions means that we are putting multiple transformations together. In this case, we are going to put multiple reflections together. And in this case, we are going to be reflecting over parallel lines. So we'll do multiple reflections over parallel lines. And then we'll do an example where we reflect over different intersecting lines. So I kind of want you to figure this out on your own because I know that you can do this. First, what I want you to do is to complete these reflections. Notice that these two lines would be parallel lines because they are both vertical lines. I want you to start with triangle ABC. First, reflect it in the line x equals -2. Then reflect that image in the line x equals 3. All right, check your work. Next, I want you to look at this and see if you can figure out a single transformation that would complete both reflections. So I want you to see what transformation could take you directly from this first triangle to the final image. What transformation could you use to get from the first triangle to the final image? All right, check your answer. If you said a translation, you are correct. Hopefully you included a vector with that to be specific. And in this case, we are translating every point to the right 10 units. So it would be the vector 10, 0. This will always work. Every reflection over parallel lines is always equal to a translation. The translation has to be perpendicular to the two lines. So for example, since in our problem our lines were vertical, our translation went horizontal to the right. This makes a right angle. The distance that we have to travel is always twice the distance between the two lines. So I want you to notice here that the distance between the line x equals -2 and the line x equals 3 is a distance of 5 units. And if we multiply that by 2, we get 10. So I knew that I had to go 10 units, and I knew that I had to go perpendicular to the parallel lines, so that would be horizontally. Now let's try reflecting in intersecting lines. So what I want you to do first is draw the segment AB with these coordinates. First reflect in the x-axis, then reflect that image, in the y-axis, then reflect that image in the x-axis. Check your answer. We start here in quadrant 1. When we reflect over the y-axis, we land in quadrant 2. When we reflect over the x-axis, we land in quadrant 3. I want you to think about this. See if you can come up with a single transformation that could take you from the first segment to the final image. How could we get from that first segment to the final image in only one transformation? If you said a rotation, you would be correct. Hopefully you specified and said to rotate 180 degrees. Every reflection in intersecting lines is always equal to a rotation. It's always going to go around the point where the lines intersect. These two lines, the x-axis and y-axis, intersect at the origin. So we are making a rotation around the origin, and it always goes through the angle twice the measure of the acute or right angle that is created by the two lines. So for example, the x-axis and y-axis create a 90-degree angle. If we multiply 90 by 2, that's how we got a 180-degree rotation. So even if our two lines were not making a 90-degree angle, let's say we were going from this shape, and we reflected over line L. And next we reflected over line M. Whatever this angle is that the two lines create, we'll have to go a rotation twice that angle. And we're rotating around the center, the point of intersection. All right, here's what I want you to think about tonight. Where could transformations be found in real life? I need you to give at least one example in 1 to 2 complete sentences. That's all I have for you today. See you tomorrow.